Hi guys, today we're looking at lesson 6. We're going to look at solving proportional relationships. This is one of my favorite lessons because we learn how to use proportions once we've identified them. And this is going to be so useful in many aspects of life. So let's get started. Our vocabulary words are proportion, which we'll talk about, and cross product, which is a great little tool that you guys are going to put into your math tool belts that you're going to be using all year long. So our real world link here, let's take a look. Fruit smoothies. Katie and some friends want to buy fruit smoothies. They go to a health food store that advertises a sale of 2 fruit smoothies for $5. What a deal. Number 1, it says fill in the boxes to write a ratio that compares the cost to the number of fruit smoothies. So remember, a ratio is nothing more than a comparison between two values. So in our numerator position here, we want the cost, which we said was 5 smackaroos. All right, and with that $5, you get, count them, not 1, but 2 fruit smoothies. All right, so there we go. All right, we have a ratio comparing cost to the number of smoothies. Well, suppose Katie and her friends buy 6 fruit smoothies. They're smoothie binging here. We want to complete the ratio that compares the cost to the number of fruit smoothies. Well, we know she has 6 smoothies. All right. Well, we know 2 smoothies cost $5. So let's ask ourselves, how many groups of 2 are in that 6? Well, if we were to take 2 smoothies plus 2 smoothies plus 2 smoothies, that gives us 6 smoothies altogether. Well, remember, every one of these 2 smoothies is $5. So if we have one group of 5 plus another group of $5 plus another group of $5, we get $15. So it's $15 for 6 smoothies. And they ask the question, is the cost to the number of fruit smoothies, is the cost proportional to the number of fruit smoothies for 2 and 6 smoothies? Well, if we take a look at this, we would say that $5 for 2 smoothies reduces down to 2.5, all right? And if we looked at our other ratio, $15 for 6 smoothies, if we divided that out, that gives us, you guessed it, 2.5 as well. All right, so since the ratios have the same value, the cost is proportional to the number of smoothies. There you go. And before you ask, yes, you have to write that down. So what is a proportion? All right, well, a proportion is basically an equation, and it's an equation that says that 2 ratios or rates, because remember, a rate is a type of ratio, are equivalent. And equivalent is kind of a fancy way of saying they are equal. They have the same value. So if you take a look at numbers here, here's an example of this equation. All right, it's an equation because we have an equal sign, and we say that 6 over 8 is equal to 3 over 4. All right, if we were to do this algebraically, you could say A over B is equal to C over D. Now remember, B can't be 0 and D can't be 0 because we can't have zeros in our denominator. All right, so down below here, we have a little algebraic proof for what cross products are. I'm not going to get deep into that because we'll talk a little bit more about what's going on there when we do our equations and expressions unit. So if you want to take a look at that on your own, you're more than welcome to, but I want to focus down here on this notion of cross products and what that is. So the products AD and BC are called the cross products of this proportion. So the cross products are the diagonals. So if you look at this little diagram here, these are your cross products. 6 and 4 multiplied together. That is one cross product. And as you can see, if you take 6 times 4, it gives you 24. Then 8 and 3, the two that are diagonal from one another again, all right, can be multiplied together. And check this out. You get 24 as well. And this is what's cool about cross products. If you multiply the cross products of any proportion, those cross products are equal. So it's one more check to determine if you have proportionality. If you have a proportional equation, multiply your cross products. If you get the same number, it's a proportion. If you don't get the same number, it is not a proportion. So let's look down here at example 1 and see what are we going to do with this. All right. It says after 2 hours, the air temperature has risen 7 degrees Fahrenheit. Write and solve a proportion to find the amount of time it will take at this rate for the temperature to rise an additional 13 degrees Fahrenheit. Okay, so we're going to write a proportion. Remember, a proportion is an equation. It's an equation. All right, so the first thing I'm going to do is I'm going to write my equal sign because I'm going to have something on both sides of this equal sign because it's an equation. All right, so I'm going to have two ratios or rates on either side of my proportion. So right there, you're looking at kind of the skeleton of a proportion. All proportions kind of look like this before we put any information in. All right, and we're comparing the temperature as it relates to time. So I'm given that after 2 hours, the air temperature has risen 7 degrees. So on the left side here, I'm going to say that at 2 hours, the temperature rises 7 degrees. All right. So it says in the question, though, how long will it take at this rate for the temperature to rise an additional 13 degrees Fahrenheit? Well, I want to know how long it'll take to rise 13 degrees. But right here we have time. That's the piece I don't know. That is my unknown. So I'm going to use a variable there. I'm going to use the letter x, all right, to represent that unknown amount. Now here's what we can do with those cross products. Remember, we know this is a proportional relationship. So we know if we multiply our cross products, they should be the same. So let's do that. Let's multiply our cross products. I'll start with 2 and 13 right here. All right, if I multiply 2 times 13, all right, I know that's going to be equal to my other cross products, which in this case is 7 times x. So that's 7 times x. All right. Now I can start solving for this. 2 times 13 is 26. 7 times x is 7x. And then the last thing I'm going to do, and this jumps ahead a little bit to our solving equations unit, but this is a real quick one-step equation. All right. How can I figure out what x is in this situation? Well, I'm going to divide by 7. And if I do it there, I have to do it to both sides. So I get x is equal to, comes out to kind of a funny number, but I'm going to get about 3.7. So the answer to my question here is that how long will it take for the temperature to rise an additional 13 degrees? It will take 3.7 hours. All right, let's look at example 2. It says if the ratio of type O to non-type O donors at a blood drive was 37 to 43, how many donors would be type O out of 300 total donors? All right, so this ratio they give you is a little bit different. This is what we call a part-to-part ratio, whereas most ratios we look at are part to whole, where you compare one piece of a whole group. All right, so the funny thing is we have to do a little bit of a trick here. All right, so let's rewrite this ratio as our 37 type O donors. All right, and then what is the total amount of donors? Well, we know we have 37 type O, and for every 37 type O we have 43 non-type O. So in reality, our total donors is our 37 type O and our 43 non-type O. So our traditional part to whole ratio actually comes out to be 37 to 80. So for all of your donors, if you have 80 donors total, 37 should be type O, all right? And the remainders are your non-type O. So it's 37 out of 80 total people, all right? So now that we have that nice, easy proportion, all right, we can figure out how many type O donors we would have if we had 300 total donors. So again, let's build our skeleton for our proportion, all right? So our type O donors are 37 out of 80 total people. And in this case, we don't know how many type O donors we have. So I'll use a little t. And then our total donors is 300. So if we had 300 donors, we don't know how many of them would be type O donors yet. But we do have this proportional relationship between type O donors and the total number of donors. So we set up our proportion. All right, so let's do some cross products. We've got 37 and 300. Slide this down. So that's 37 times 300. And we know that is equal to our other cross product, which in this case is 80 times t. So we work this out. 37 times 300 in my head, beep, boop, boop, beep, gives me 11,100. Aren't I impressive? And then 80 times t gives us simply 80t. So how do we get rid of that 80 on our t? Well, we divide each side by 80. And that tells us that the total number of type O donors is 138.75. But Mr. Downing, how can we have 0.75 of a donor? We cannot. So there would be, my answer over here, about 139 type O donors. So it says you can use the unit rate to write an equation expressing the relationship between two proportional quantities. So let's take a look at how we do that. Remember, a unit rate is simply a rate where you reduce the denominator to 1. So, example 3, Olivia bought 6 containers of yogurt for $7.68. Write an equation relating the cost C to the number of yogurts Y. How much would Olivia pay for 10 yogurts at this same rate? So we're going to find the unit rate between the cost and containers of yogurt. So we said that for 6 containers, cost $7.68 here. So if we look at cost, that's $7.68, and that gives us 6 containers of yogurt. Well, we want to reduce that so that it is how many are in one container. All right, well, to get 6 to 1, divide by 6. That gives us 1. We'll do the same thing then to your numerator. What's $7.68 divided by 6? That comes out to $1.28. Or, as we could write it, $1.28 per container. Okay, well, if we know that one container costs $1.28, we can write a little equation here to find the cost for 10 containers. So C represents the cost. So the cost for any number of containers of yogurt would be that $1.28 times Y, where Y is the number of yogurts. So for example, the cost for one yogurt would be 128 times 1, or 128. So we want to know how many is it for 10 yogurts. 10 yogurts. So that becomes $1.28 times 10 yogurts. We would simply replace the Y with 10. We multiply. Since this is simply just a multiple of 10, we can kind of just slide that decimal point over 1, and that gives us $12.28. for our 10 cups of yogurt. So let's see that in one more example here using that unit rate again. So we got JC bought 8 gallons of gas for $31.12. Write an equation relating the cost C to the number of gallons of gas, or G. How much would JC pay for 11 gallons at this same rate? So again, let's find our unit rate. Cost in dollars, we said, was $31.12, and that got us, 8 gallons of gas. So $31.12, 8 gallons. All right, so we want the cost for 1 gallon. Converting 8 to 1, we divide 8 by 8 to make it 1. So we'll divide $31.12 by 8, and that gives us $3.89, or $3.89 per gallon. There's our nice, easy to use unit rate. So again, write an equation. So C represents our total cost. We want to know the cost for any number of gallons of gas. So it's $3.89 times the number of gallons. And we use G for the number of gallons. All right. So we want the cost for 11 gallons. So we'll replace G with 11. That gives us a cost of, drumroll, $42.79. So use your newfound knowledge, do the guided practice, and we'll talk.